The area of a regular polygon can be found by doing 1/2 perimeter apothem. And this applies to all regular polygons. A regular polygon is a shape where all the sides are equal length and all the angles are equal measure. All equal sides, all equal angles. The apothem is the measure of one triangle. If a triangle was drawn to each of the corners, sometimes that's called a radii. The radius goes from the center of a circle to the outside of the circle. And if it goes to the vertex, we call that a radii as well, if it's on a regular polygon. Each of those triangles has a height, and that height is called the apothem. So the apothem is the height of one triangle on a regular polygon if you draw triangles using radii. Okay, on this particular problem, the apothem is 5√3. Now we need to find out what the side lengths are so we can find the perimeter. Okay, we know the apothem. Now we need to find the perimeter. All right, so one formula that we can use for finding the sum of the angles of a regular polygon is the number of sides take away 2 times 180. Number of sides take away 2 times 180. So this is a hexagon. It has 6 sides. You take away 2, that's 4. 4 times 180 is, what, 720? No, 4 times 180, yeah. 4 times 180 is 720. So the angles have to add up to 720. In this one, 6 take away 2 times 180 is 720. If you divide that by 6, divided by 6, you get that each of the angles is 120. Well, we're going to split it with a radius. So we take that 120 degrees. We split it with a radius, and you get 60 degrees. We go straight down with our height, or the apothem, and that's 5√3. We have this triangle, 60, 30, 90. So we've got a 30, 60, 90 triangle. If the apothem or height is 5√3, then I know the side's 5 and the radius has to be 10. On the 30, 60, 90, the hypotenuse is double that short side. So that would make each of the side lengths 10. 10 times 6 is 60, so the perimeter is 60. So the apothem is 5√3. The perimeter is 60. So the area of this hexagon would be 1/2 times 60 times 5√3. And you can put that in your calculator. We'll round to the nearest tenth on this. Let's see, 30 times 5 times the square root of 3 would be 259.8. Okay, so down below here on number 3, we have another hexagon. This time we have the side lengths. We know that we're going to have a 30, 60, 90 if I do the apothem. Same shape, so it's 30, 60, 90. 60, 30, 90. And the radius on this, as we saw in the last one, is going to be the same as the side. So your hypotenuse is, maybe I should draw a bigger triangle. There's 60, 30, 90. If the hypotenuse is 26√3/3, then the short side's going to be 13√3/3, and the apothem would have to be that times √3. Let's see, that would just be 13. So the apothem is going to be 13. So we have 1/2 times the perimeter, which is 6 times 26, which would be, the perimeter would be 156 root 3 over 3 times 13. So 1/2 perimeter, apothem. There's the perimeter, there's the apothem. So let's see. Times square root of 3. And we get the area on this one is 585.4. Okay. Let's see. On this one, number 5, we have the radius, which is 32. On all equilateral triangles, the angles are going to be 60. If you split that with a radius, you're going to get a 30, 60, 90 right triangle. Let's see, if this is 32, then your side across from the 30 is going to be half of it, 16. And so let's see, so that's your apothem. Your apothem would be 16. Your perimeter, let's see, that'd be 16 root 3. And this would be 16 root 3. So each side is going to be 32 root 3 times 3. So your perimeter is going to be 96 root 3. And so then we do 1/2 times the perimeter times the apothem. Let's see, so that's and that would equal 1,330.2 for your area.